Here's the process I use to memorize all the important amino acids. The first step is a mnemonic. So the mnemonic I like to use has to do with a little imp holding a gavel. Gavel is sort of a hammer, I suppose, that all the judges might use in a courtroom drama. So here we have a gavel. I'm going to put the E lowercase and an imp. This is really the beginning of everything. After this, it gets really easy. So I watered this down to the mnemonic gavel imp. And this is super helpful because you don't just have to memorize amino acids sometimes. In addition to the amino acids, you also need to memorize their one-letter code, which is what's often given when you're solving point mutation problems or something of the like in a research paper, you're reading it and giving an exam. So the nice thing is these first 7 amino acids match the starting letter. The first letter, the letter given to them matches the first letter of their name. So G is glycine. A is alanine, V is valine, L is leucine, I is isoleucine. It's not really uppercase L, I'm just doing that here. It's not really uppercase. M is methionine. And feel free to check my spelling. That's not quite as important when you're reading passages because you'll be able to figure out methionine with an E or an I. You'll still read it as the same amino acid. P for proline. So these are the first 7. They get you started, and after that, it gets a little easier. Another thing is, so to know about this, is these are non-polar and non-aromatic. And that may be a little bit harder to remember. I don't have a clever mnemonic for that. You may come to those realizations, or you may come to that memorization over time. So I would say don't worry about it too much. But gavel imp, right? You've got 7 out of 20 amino acids right there. Not just that, you've got their one-letter code. So that's a great start. Another thing you may not be comfortable right off the bat is the names glycine, alanine, leucine. How are you supposed to remember that? Honestly, it just gets easier the more you look at them because you think A and you just can't come up with anything, any random name for an A because all you've ever seen is alanine. So after a few tries, your mind just goes to alanine, or L just goes to leucine because there's really not that many names you can think of. I mean, you don't know 100 or 200 amino acids, right? So these are the only 20 you know. And after a little while, as long as you know the starting letter, you'll be able to think of the full name. So that's just exposure, I feel. The hard part for me was the first letters. So gavel, imp, right? The first 7. Next, we'll work on the cyclic ones. So there are 3 cyclical or aromatic. Because aromatic is slightly different than cyclic, I'm going to use the term aromatic. Aromatic implies conjugated cyclical structures, not just cyclical, but also conjugated, which means they have pi bonds. Okay, here we go. And for aromatic, I like to think of, I have 2 mnemonics here. So what I like to think of it is arrow, trip, penalty. And that'll make sense in a second. Why am I coming up with that, right? So I just imagine somebody jumping up and trying to dunk a basketball, right? There's a net, swish, right? And they get tripped up, so there's a penalty. Anyway, the important thing here is Aero stands for aromatics. That reminds me that this is my mnemonic for aromatic rings. And trip is for tryptophan. And phenyl is for phenylalanine. So that's just, there's a little bit of hint there. A lot of these structures will just be alanine with a little bit extra. So that will make things easier as you come to recognize those patterns over time. And TY is for tyrosine. Kind of gets me started. Tryptophan, phenylalanine, and Ti for tyrosine. Another nice mnemonic, if you want to just forget about this whole business with the aerotrip penalty mnemonic, is Wi-Fi, right? If you're on the air, you're using Wi-Fi, right? And that actually really helps with the single letter codes also. So W, F, Y, not I, right? Wi-Fi, you can think of it that way, Wi-Fi. And that really helps me because you can just say gavel limp Wi-Fi, and right away you have the one letter codes, which is, by the way, hard to get. And then you have the names. But, you may not be used to tryptophan, phenylalanine, tyrosine in that order. So aerotrip penalty, or as I write it, so let's change that a little bit. So aerotrip penalty, right? That's a way you can remember the actual names, because W might not jump out at you as tryptophan. So one mnemonic, Wi-Fi, is for remembering Wi-Fi is for remembering this, right? And the other mnemonic, aerotrip penalty, is for remembering the names. Next, you have something tricky, which actually, there are a lot of mnemonics out there. Some may be better than mine, so feel free to look around on for videos online. But I like to think of it with the name set and a glass, like pouring a glass of alcohol or some other beverage for a person named Seth. So I just say pour Seth a glass, a classy glass, so glassy, right? The hints I'm giving myself here is that these are polar, that there's something that starts with SE and TH. There's something that starts with GL, AS, and for glassy, classy glass, I'll just say it sounds like this, but I'm thinking of this. So let's go. Let's see how that works. SE, serine. TH, threonine, I believe. GL, glutamate, right? See, only so many names, they'll come to you. AS for asparagine, and CY for cysteine. This extra E stands for that this cysteine has more electrons in it. It's the more reduced version. So when writing cysteine, there are two cysteines actually. There's the oxidized form, which means it has less electrons or less electron cloud or a bigger oxidation number, if that rings a bell for you. That's written like this. So that's the oxidized form. That's not what we're talking about. What we're talking about usually here is the form that has a lot of electrons or has more electrons, is more reduced, cysteine with an E, E for electron. So these are your polar. And yeah, I mean, actually I've seen it either way. Some people say cysteine is not polar side group, and I can't decide. I mean, I just go by the reference book I read. If your textbook says otherwise, feel free to follow your textbook. I know professors can be really difficult. They all think their textbook is correct, and nobody wants to admit that the 5,000-page textbook that they refer to could be wrong. So, and same in my case. So I'm just going to stick with cysteine as polar. Okay, moving on. So this is the trick, pour Seth classy. That's how you get it. Now for the letters, the nice thing is there are very few letters that are that do not match the first letter of their amino acid. So serine is just S, threonine is just T, cysteine is just C, because there are apparently no duplicates, or if there are, these guys came first or these gals came first, so they took the letter and that's it, right? Now glutamate and asparagine, I don't know how I do it. I just remember queen because there's a classy glass, there's classy glass, glassy. So classy tea time or something. I just remember queen, Q and N, queen. That's how I remember that. I hope that's of some help to you. Okay, and now we just left with 5 more. The nice thing is the next 2 are acids, and they can be negatively charged at physiological pH, which is 7.4. So they're actually just offshoots of these. So they're, instead of glutamate, it's glutamic acid. When I say offshoot, I don't mean like literally offshoot. What I mean is they're similarly named and close in structure. Glutamic acid. And there is aspartic acid. Again, the names, you'll get used to it. The harder part is just remembering all of them or having a clue to list all the first letters of all 20 of them. So it'll get easier. And for this, I use glue. I should make it better. Glued as acid. So the acid part is clue that, this is my mnemonic for acids. The glue is my clue for glutamic. The as is my clue for aspartic. Now the E and the D, they tell me that glutamic acid and aspartic acid, they're symbols. So glue, the E is closer to GLU, so that's the symbol for glutamic acid. D, glued as acid, the D is closer to aspartic acid, so D is the symbol for aspartic acid. That's how I remember that. Right there, and right there. It seems like a lot, but trust me, when you can't find any mnemonics at all, and you can't seem to memorize it, these 3 or 4 mnemonics really go a long way all of a sudden. And the last 3 are basic highlighter. Basic highlighter. That's highlighter like outlier. And I actually remember it like this. There are 2 ways you can remember it. High, or highlighter, basic highlighter. And so obviously we're talking about basic side chains that are positively charged at physiological pH of 7.4. That doesn't make any sense. That's fine. You can read up on that at a separate point in time, what physiological pH means. And yeah, so they're basic. Highlighter, oh, okay, that's histidine. Gets us started with the HI, lysine. Gets us started with the li. AR, arginine. With the AR, right? And I don't know how, but since the A, A was taken by alanine, so they had to give it something else. And arginine, there's an R in it, so they started with R. And for H, there's nothing that starts with a H, I suppose, nothing else that conflicts with it. So they just kept the letter H, and lysine is a K. So let me just put squares around the ones that don't match the first letter of their name. So Gavilan. So really, Wi-Fi, Queen, and RKH, well, not H, but RK, are the only ones that don't match the first letter of their amino acid name. Okay, so for this, I don't have anything clever. Somehow I just ended up memorizing RKH, and if you can come up with one, great. It's just when I was going through it in sequence, these were the last 3 things left, and it just clicked. RKH, okay, RKH. And that's of course in reverse of histidine, lysine, arginine. All right, so now you have a way to think of all the names. Let's give it a shot, right? Let's practice. So amino acids, 1 letter. Gavilimp, okay, so I'm just gonna go with Gavilimp. Just gonna go over here and say there's gonna be a G, there's gonna be an A, there's gonna be a V. I'm gonna skip the E, Gavel, just Gavilimp. So I know I got my letters right. And what else is there? Well, there's Wi-Fi, right? So W, because aromatic, right? F-Y, Wi-Fi. Okay, I got that. Then there's, this is a little hard, polar, pour set, glassy set was S, TH set, T, glassy G, A, glassy, okay, you know what? I'll do it differently. Pour set, glassy, set, glassy, glassy, right? Glassy. Okay, now that I got that, now it's a little easier because S for S, T for T, S for S, T for T, A for A. No, wait, no, that's not how it works. Sorry. C for C, and then the queen, right? Glassy, something to do with the queen QN, right? And these are the ones that don't match the first letter. So I'm just gonna point those out as things we memorized, Wi-Fi and queen. Okay, what else we got? We have then acids, right? And acids are just offshoots of these. So glutamic acid and aspartic acid. So glutamic and glued as acid. Okay, let's just use our mnemonic. Oops, glued as acid. So glued, glutamic, glued, glued as acid, right? Glued as acid. And so that's glutamic. That's aspartic acid. That's cysteine. That's aspartate. No, that's not aspartate. That's asparagine. Asparagine. And you're gonna make a few mistakes, but you'll get used to it. This kind of stuff. Glutamic, glutamate, glutamine. Asparagine, glutamine, threonine, right? Serine. We could do this all day long, but we're just worried about the symbol, so we'll move on. So E and D. Let's just write them uppercase. E and D. These are different. Now histidine, basic highlighter, right? High histidine, lysine, arginine. So R, K, H. Histidine, lysine, basic high, here, arginine. So pretty much done, and I'm not gonna maybe, well, okay, let's aerotrip penalty, tryptophan, F-phenylalanine, phenol, right? Penalty, something like that, phenylalanine, then that's just alanine. Tryptophenyl T, tyrosine, penalty, tyrosine. And these should be easy, hopefully, with enough exposure. Glycine, alanine, valine, leucine, isoleucine. Oops, not that I'm spelling these correctly, so maybe I shouldn't care so much. Methionine and proline. Okay, we got pretty far. We know 20 amino acids, hopefully, and we even know they're one letter shorthand. Now the trick is memorizing the diagrams so we can recognize them when we see them. This is gonna be slightly bit harder, but with time it'll work out. So glycine is, well, all of them have something in common, which is this structure. Depends how you are used to drawing it. This is the basic structure of any amino acid, right? This is called the alpha carbon. Here we go. So this is going to be present in each and every one of them. You can't get around it because that's what it means to be an amino acid. Everything else is a side chain on an amino acid, something a little bit extra that differentiates it. And that is why we have different names for them. Because if they were the same, we wouldn't need different names. So here we go. I'm just gonna copy paste it everywhere so we can hopefully save some time. Let's see how fast I can do this. Not super fast, but acceptable. Oops, that went the wrong way. And hopefully you're seeing a pattern here. You just got COOH, right? This represents carbon, and then there's a carbon joining the COOH group and the NH2 group, and that's what makes it an amino acid. Got nitrogen and an acid, alcohol acid. OH represents an alcohol. Anyway, here we go. So we're ready, right? We got NH2, we got COOH, and we got the alpha carbon that joins them. Now, and by the way, this dot right here, that's carbon that I'm not writing out. So that's that's the C of COOH, right? And this is an extra carbon which is joining them, and that's called the alpha carbon. Here we go. So in glycine, you just have two hydrogens. So one hydrogen was going to be there, and then the side group is, by the way, another hydrogen. Usually in skeletal diagrams, hydrogens are not shown, just like carbons are not shown, they're implied to be there at the end of this stick figure. But in this case, because there's no other carbons, we're just going to show the two hydrogens. So that's glycine. It's achiral. Not going to get into this in this video what that means or why that's important, but just throw that out there. If you don't want it, don't have to think about it. For now, this is just the diagram. Now what happens is, think of it as it starts growing, right? It gets another carbon. So I'm not going to write it, but kind of just show it with a dot, or even not the dot. Just know that that's CH3. I could write CH3, but usually what's assumed by convention is that if you have this thing sticking out, it could be nothing but carbon with a bunch of however many hydrogens are needed to complete its octet. So that's CH3. Then from 1, it goes to too long, but it kind of gets another one. People like to think of it as a fork, right? For valine. So you have still your alpha carbon, but now you have this 1, 2, 3 other carbons. All good? And this only had 1 carbon. Now this snake of sorts grows a little bit more. So it had, it had grown a tail or a tongue, however you want to think of it, in addition to what it already had. And that now goes a little further, right? So now it's 1, 2, 1, 2, 3, 4. I don't know if you can imagine this part kind of having, initially was 1, 2, 3, and now it's kind of grown out with an extra. So now it's 1, 2, 3, 4, but it's still the same kind of fork tail that started with V for valine, and that really helps, the fork tongue starting with V for valine, as you're doing this incrementally in your mind. And when you do it incrementally enough, when they're shown to you randomly, you'll be able to do it then much more easily. Isoleucine. Okay, so again, it's leucine, so it's something they're related. Yes, they both have 4. They have 1. So this is kind of funny. If you know anything about what the word iso means, what you're gonna think that this is not an iso, this is a sec, but let's not get into it. This is how they named it. 1, 2, 3. Now the 4th one, instead of being here, it is actually up here. That's how you can remember it. So 1, 2, 3, 4. And those are the carbon ends. So, CH3 here, CH3 here, CH2 here, and CH here. The H is implied. You put as many as you need to complete the octet. If that's confusing, you can just forget about it for now, because that's chemistry and chemistry. Okay, so we started with 1, we pushed it out, we ended up with 1, 2, 3, we pushed it out a little bit more, we got 1, 2, 3, 4. We changed the location of the dangling carbon, and now we have methionine, which is just 1, 2, 1, 2, and then sulfur jumps in the middle, but then finally there's another carbon, 3. I don't have any clever mnemonics, just showing you my process, and hopefully if you come up with something better, you will share, or you'll just get used to practicing. All right, proline. So what happens here is there's 1, 2, 3, and it just loops around. 1, 2, 3, and then it loops around and connects here. Now, if you are keeping track of, or used to keeping track of hydrogens, nitrogen can have only 3 bonds. So one of the NH2 has to go away, right? Because you got 1, you got 2, and then you got a bond to hydrogen. So nitrogen cannot possibly have NH2. So that's how I remember that. I clean it up. Now tryptophan. So the nice thing is the W, it really helps. So there's something looking like a W here, okay? The next thing is their aromatics, and so you gotta have like a ring structure, so something like a ring. Only one, I suppose, if you look at it in its entirety, only one amino acid has a really big ring structure where it has 6-member ring and a 5-member ring. So I'm just gonna draw 6-member ring and a 5-member ring. And the direction of this is because of the W, right? Why didn't I point it up? Because I remembered the W. So it was easier for me to kind of get this done. And now everything is kind of, anytime you have something big or weird sticking out, it's just gonna hook up with a simple hook up, like just, I don't know how to draw that, 1 up, right? So there's gonna be just this 1 extra carbon sitting between your super big chunk extra thing and the alpha carbon. That's how I like to remember it. Now these are aromatic, which means they're conjugated. Put double bond, then skip one. Put the actually easier to do it this way. Put a double bond between these two, then skip this one and you get here. Skip this one and you get here. Now, if there's a double bond here, I can't have it here or here, right? Because that's adjoining, and we got to skip. So the only other place I can have it is here. Now this is too much carbon. You know, some nitrogen is always thrown in there. Well, nitrogen is usually sitting there at the peak of these. So what it actually looks like is like that. It's a 5-member ring with nitrogen sitting here. Now this nitrogen has how many bonds? 1 and a 2. Oh, 1 is missing, so we got to give it an H. And now you have a complete tryptophan. You started with the W. You went on to this conjugation. You figured out these two. From that, you figured out this. Then you're like, well, I need a nitrogen. You figured out this. Nitrogen needs 3 bonds, so you figured out there's an H. And you wanted to, you know, latch it onto the NH2COOH. So you figured out you need something in the middle to latch it on. And there you have tryptophan. Phenylalanine is luckily simple. It's just 1 hex conjugated benzene ring, and then you tack it on with another thing in the middle, and there you go, phenylalanine. And actually, it even looks like alanine, because if you look at this right side, that's alanine, right? Alanine has just 1 carbon. So you just took the phenyl part, which, if you know OChem, means a benzene ring, and you tacked on phenylalanine to it. You tacked on alanine to phenyl, and you got phenylalanine. So that's fairly simple. That's right there in the name. Tyrosine, well, it packs a little punch, right? So it packs a little punch. It has a little OH to the side, but other than that, it's the same as phenylalanine. It's a benzene ring tacked onto NH2COOH with alpha carbon, and there you go. You have your phenylalanine changed into a tyrosine with the simple OH, because tyrosine, you know, famous boxers that start with TY, if you can think of them, you know, they pack a punch. So here you have a little bit of a OH on the side packing a punch. Serine, okay. Serine and threonine take a little getting used to. They have to do with the fact that they have an extra OH in the side chain. So everything we've been doing until now after the alpha carbon constitutes a side chain. It's the something extra. So these side chains have to do with OH. So serine, S, I think of from S, I think of second or the number 2. So I know there's 2 things I got to put. So right away, I draw 2. And for threonine, I know I have 3 things I have to put. So I could draw them like this, but I kind of remember it's a little bit off. So I draw it like this. So I drew 2. I'm ready to put 2 things here. 1 here, 2 here, 1 here, 2 and 3 here, right? Now, it just so happens the thing over here is not carbon, it's OH. For threonine, it's on top. And for serine, it's on the left. So that just takes some getting used to. And you can think of it as 1, 2, 1, 2, 3. Or if you don't want to count the oxygen as you know, part of your carbon numbers, then not that I've been numbering very nicely. You can just do this 1, 2. So for threonine, you can think, oh, just 1 less. You know, I need 3 components, but carbons are 1 less. And then you just do 1, 2, and then the third component is OH. And for serine, you say, oh, I will need 2 components. I'm going to get ready. But by the way, only one of them is carbon and the second one is OH. So those are some ways to think about this stuff. So let me just finish numbering this. Okay, glutamine. Okay, what glutamine is, again, kind of tricky. You just have to remember that it says NH2 plus glutamic acid will have the acid part. So glutamine, which is then not an acid, will be a little more, not basic, just more on the NH side. So NH2, which is, you know, kind of, NH2 is on one side of the pH spectrum and COOH is on the other side of the pH spectrum. So let's get it ready. So glutamine, the way I remember it, actually I do glutamic acid first. E, right? E has 1, 2, 3 things sticking out. D has 1 and 2. That helps me remember because they're very close and it gets to be a pain. Then I want 1, 2, 3 carbons for glutamic acid. Then I'm going to put an acid on it, which is COOH. And 1, 2, 2 carbons. Then I'm going to put an acid on it, OOH. right? So that's how I do aspartic and glutamic. Then I just come back with the same analogy. 1, 2, 3, 1, 2, 3 for glutamine, and then I'm going to put NH2 on it. Well, not NH2, oxygen and NH2. And 1, 2, 1, 2. Then again, I'm going to put, the ONH2 pair. On the other hand, the acid had the OOH pair. So hopefully that makes some sense. 1, 2, 3 for E, 1, 2, so 1, 2, 1, 2, 3, and then it's an acid, so it gets COOH, whereas glutamine and asparagine, they wouldn't be the same thing, so there's got to be something different. So instead of COOH, they get OH2N, and still the same 1, 2, 3 analogy, 1, 2. Okay, moving on. Cysteine, very easy. You just, you got to put a sulfur on it somehow. Sulfur is like oxygen, needs 2 bonds. So one bond will be to the hydrogen and the other bond it'll use to latch itself on. So, I might even have called it sulfur alanine because there's the alanine part and then the sulfur part, but whatever, they get to name it. So they call it cysteine. So that's cysteine. Cysteine has sulfur and methionine has sulfur. Those are the only 2 that have sulfur. Where did it go? There it is, sulfur. Okay, now that we've done with this, last 3, histidine. Okay, histidine, it doesn't really look like an H, but somehow I got used to it. I draw this bucket first and I say, well, H has a line somewhere. So I don't know how, but somehow this reminds me of H. I don't know how I manage that, but that's, and then I know it's got to have 5-membered ring, so I connect it. Now there's some nitrogens in there. I know there's always a nitrogen on the peak. That seems to be the trend. And there's a nitrogen on the side here too. So now I'm going to redo it. Now that I've remembered everything I want to do, I want this, I want this. I know there's a nitrogen here, and I want to just connect these. I want this, I know there's a nitrogen at the peak. Okay, I got that. And of course, latch on. So just 1 more carbon to latch on. And now what about the nitrogen, right? So it has, needs 3 bonds. 1, 2, where's the third one? Not there, gotta give it a hydrogen. Okay, what about this nitrogen? 1 and 2 bonds, 3. Okay, it's happy, we're done. That's histidine. Next, lysine. Okay, I just remember the number. So 1, 2, just looking for the vertices on K. I say 1, 2, 3, 4. 1, 2, 3, 4, and then all of these are basic. Histidine, lysine, arginine. That's why I use the mnemonic basic high liar, right? That's why I call it. So if they're basic, they need NH2, right? So okay, fine. Here's your NH2. Done. Now arginine is like a beast. So the first thing I learned to remember about arginine is, well, I'm done with everything else, so there's only 1 combination left, but that there are 3 types of nitrogen. There's I don't know if this will help you. There's a nitrogen with a simple sigma bond. There's a nitrogen with a sigma pi bond. There's a nitrogen with a sigma sigma bond. Now this makes no sense, then I'll erase it, but just follow me. So I know that there's going to be a nitrogen like this. That's the first thing I remember. There's a double bonded nitrogen. And then on the left and the right, we need something. Now, all the basic amino acids have NH2, so I throw that in there. So here I feel like I've got NH2, I've got N, so I need 1 more N. And then I realize, oh wait, there's like just 2, so I need a H here. This is gonna tack on to something, so this is gonna have 2 bonds, so it needs a H here, because otherwise it's not complete, right? Okay, now I'm ready. Now it just has 3 more things. 1, 2, 3, and it's tacked on. Let me draw that better. 1, 2, 3. So 1, 2, 3, right? Just like there's 3 nitrogens, there's 3 carbons to connect and latch it onto COOH NH2 amino acid. And we're done with arginine. I hope this is helpful, and best of luck on your amino acid memorization.